So I'm Alan Chiu, founder of Boba Network. Boba is a new Ethereum layer 2. It's an optimistic rollup. But it's much more than that because we started Boba with the mission of making the benefits of crypto and Web3 available to everybody on the planet. And today, I'm going to be talking about hybrid compute, which is an important step towards realizing that vision, realizing the full potential of Web3. Now, the fundamental premise of Ethereum from day one is the belief that while a distributed, a decentralized ledger is good, a computer is better. And our hypothesis is if you could get this decentralized computer to be more connected, then we end up creating a more creative and more powerful decentralized systems. And we're giving these powers to developers to build more amazing dApps for more users. Looking back a little bit in history, there was Bitcoin, right, and then Ethereum. And Ethereum came with a Turing-complete programming language. All good. But the problem, though, is what you can do on an Ethereum smart contract is quite limited. If you compare the compute performance of Ethereum, layer 1 itself, to a computer from decades ago, and even since Ethereum launched, it hasn't really changed much. And that's okay, that wasn't really Ethereum's goal. Its goal wasn't to optimize for raw compute performance. But then, how do we take advantage of the latest advances in computer science, like deep learning and advanced cryptography, and a lot of interesting things that require a lot more compute power? The fundamental issues, we're trying to do all that on Ethereum itself, is that getting many computers to agree on anything is really hard. Because not all of them are going to be connected at the same time. There's network latency. The list of issues goes on and on. And so in order to achieve Ethereum's goal, it had to dramatically simplify and constrain what a developer can do in a smart contract. And therefore, you can only do integer-only operations, and you can't do really random number generation directly. Those are the necessary sacrifices to make Ethereum work. Now, there have been a number of possible approaches to break away from these constraints. We've listed a number of them here. TrueBit is truly very ambitious in trying to do probabilistic verification game protocol. They've been working at this for 4 or 5 years now. Chainlink, they have their way of introducing real-world data into smart contracts used by a lot of developers. And different attempts at verifiable computation. Won't go into details here, but we included a link in the deck so you can read it up afterwards. But we came up with a new approach. Now, the rise of layer 2s has only just begun. And the initial design goals for layer 2s on Ethereum were to reduce cost and scale performance because Ethereum is maxed out. Well, as it turns out, there's actually an additional major benefit to L2, which is to help us scale compute as well. Now, all the layer 2s today are single sequencer layer 2s. There's only one instance of a block producer. That is a limitation, but at the same time, it opens up the possibility of allowing smart contracts to interact with outside computers. Because now we don't need to deal with the challenges of needing to have a lot of computers, a lot of different nodes to agree to the same compute results. Because there's only one instance of a layer 2 sequencer. And now in the future, we'll evolve hybrid compute to support the scenarios of multiple sequencers, as long as only one of them is responsible for producing blocks at any one time. So what we have built, and is available today on our Rinkeby testnet, is a modified version of layer 2 Geth. We call it LZTGeth, T for Turing, which is our codename for hybrid compute. And we're releasing it on our testnet with atomic support for random number generator and client call functions. Let's dig deeper into this. So LZTGeth is a flavor of Geth Go Ethereum for layer 2s to enable hybrid compute. What this allows you to do as a developer is you can write in your smart contract, right? Call get random and get a random number back in one call, in one atomic transaction. You couldn't do this before. This is totally new. You can also even get a quote from a token pair. You can do a lot with it. You can pipe in real-world data through hybrid compute, through an AWS Lambda endpoint, for example, that is invoked by your smart contract. Think about the power of that. What you run on the RPC endpoint that you control off-chain on AWS could be anything you want, right? It could be as simple as generating a random number, or it could be as complex as a machine learning trained model. Let me give you a system overview of how this works. You might be wondering, all right, that all sounds good. How does this really work? So the way it works is, our version of layer 2 Geth would intercept certain calls and then would call the off-chain API, which then replaces the original call data with modified call data that includes results that come back from the off-chain algorithm. And then this Geth will write both the original transaction and the modified call data that includes the results coming back from the off-chain process into Ethereum layer 1. So you can do verification, you can replay that transaction, you can do fraud detection and replication, all the same functions that you expect to be able to perform on any L2 transaction. And once the L2 block is written, verifiers and replicas will use the stored API response data from the block. It's mutable. And graphically, this is how the sequence flows. An RPC call comes into the Geth. Geth checks, is it Turing? If it is, invokes a user-designated endpoint, so it's not going to call anything random. Receives a response. I won't go through the details of step 4, but it's updating the call data with the results that come back, and the modified call data is committed to layer 1. Now, there are a number of changes that we have made to Geth to make this work. Net, though, the result is the transactions that come back are stored on layer 1, so you can always replay them. And from the caller's perspective of this smart contract that is enhanced by hybrid compute, they actually won't notice that anything has happened off-chain. It's completely EVM compatible. And the system is now live today on rinkaby.boba.network. You can take it out for a spin, see what you can build with it. Start by simply getting a random number and seeing that appear in one transaction, and try to create an NFT series with it, or get a price quote. And it's going to go mainnet soon after ETH Denver. We're still working on some finishing touches, including adding a caching system. We've also built a number of example uses for hybrid compute that we're going to be releasing on our mainnet. So these are all just for fun with some utility, but the idea is to give all of the developers out there a taste of what you can do with hybrid compute that you couldn't do before with just smart contracts. For example, we have created a Twitter activity-based Boba fountain for Gateway. Who has used the Rinkaby faucet to get some Rinkaby ETH, right? We've all done that. Well, this is a similar system built on hybrid compute that would give you Boba in a similar way. And this shows you how smart contracts could actually interact with a Web2 social network. We've also built a use case to demonstrate how you could use CAPTCHA for spam prevention for smart contracts, or random number generator for NFTs. And it might not sound that big of a deal to be able to get a random number, but you'll be surprised how hard that is to do on-chain, and to be able to get it within one transaction, not have to wait for an unknown number of transactions and keep going back to check, hey, is my random number there? This is going to save a lot of headaches for developers. And you can also sign up for commercial data sources with Bloomberg or any number of data providers that you want to use. They don't even have to be quotes on tokens or stock prices. It could be any sort of data feed they can subscribe to and make that available through an RPC endpoint that you control and pipe that into your smart contract. Think about the power of that, right? And if you were a Web2 developer that's getting to Web3, you have data sources that could be coming in from your partners. It could be coming in from your own company. You can now take advantage of those data sources within a smart contract, bridging the worlds of Web2 and Web3. So our hypothesis here is that if you combine the power of a decentralized infrastructure like Ethereum and a lot of network computers around the world, that's a really powerful combination. You can get the best of both worlds together. Then you, as a developer, you get to decide what you build within a smart contract and what you build and run and execute off-chain. Now, there's no free lunch, and I do want to point out a number of caveats, at least with the current implementation of Turing. So first of all, there are security trade-offs in our current implementation of our random number generator. We, as the operator of the single sequencer, there are ways in which we can manipulate the random number generator. So you need to trust us for now for not screwing around with that, but we are building the next version of that random number generator that is much more secure, and you don't need to really trust the sequencer. There's currently not a way to verify off-chain inputs just yet. And also want to note that we haven't tackled the problem for privacy-preserving compute, meaning the off-chain endpoints that you call, they're going to see your clear text inputs that you send over. Right, so this is different from secure multi-party computation or fully homomorphic encryption. That has not been implemented yet. Well, as I mentioned before, this is now available today on Rinkeby. We have a detailed write-up. It's a technical write-up for developers at this bit.ly link, bit.ly get Turing. It is very easy to use at the smart contract level, really just to start taking advantage of these two features that we built on top of hybrid compute. Just go turing.get random or turing.get current quote, super easy. To sum it up, the fundamental premise of Ethereum, right, is to create a decentralized compute platform. And with Boba running on top of Ethereum, we're taking Ethereum to the next level. And what sets us apart from other scaling solutions is that we're not just making Ethereum faster and cheaper. We're making it smarter by letting you, the developers, to run much more sophisticated algorithms on a scalable web scale platform. You can run anything that is as sophisticated, something as sophisticated as you want, as your heart desires, and have the results come back into your smart contract, which itself remains composable with other protocols that continue to live on chain. That's the new power you're getting with Turing. So we're supercharging Ethereum with scalable compute power. What do you want to build today? Thank you.
Awesome. We have 5 minutes for questions, if anyone has questions.